When we're working with square roots, we do want to just be a bit careful. In this problem, we just need to plug in a and b. We can do that first and simplify what's underneath the square root. It's going to be 3 times 4 minus 3, which is going to be 12 minus 3, which is just square root of 9. Now, some students will say to me that negative 3 squared and 3 squared are both valid roots for 9. And that's actually correct. You do want to include negative 3 and 3 when we're thinking about what number squared becomes 9. Right? But the question, and this is where it gets maybe a little bit ambiguous, only is asking for the positive square root. How do we know that? Well, if it wanted the negative square root, it would look something like this. And this is just by convention. You might be like, well, how do I know? I've never seen negative square root. It's always been the positive one. Or how do I know when we need to use both of them? Well, there is one formula that most students who are at least kind of halfway or mostly through algebra have done, which is the quadratic formula. And over here, we definitely see a case where we're asking for both the positive and negative root. Right? And sometimes for problems, we might just see the negative root on its own. For example, let's just say we have x is equal to negative square root of 4, and that's perfectly fine. It just means, okay, when we're going to get negative 2. So in this question here, because it's the positive square root, and sometimes we call it the principal square root, we do x over 2 is equal to square root of 9, and therefore we really only get the answer 6. So hopefully this video made sense. Why don't you try this problem?